Hello everyone. In this video, we are going to discuss about the blocks in the modern periodic table. Especially we will be discussing about the S block elements from the chapter 3 classification of elements and periodicity in properties class 11 chemistry. You see, we will be discussing about the other blocks like P, D and F block elements in our coming videos, which will be available in the playlist. So in this video, we are focusing on the S block elements. You see, the modern periodic table, it is actually divided into 4 blocks based on the subshell in which the last electron enters. They are S block, P block. Okay, we have S block elements, then P block, D block and F block. See, these are actually, when you consider the S block elements, these are the elements in which the last electron enters in the outermost S subshell. Okay, S block elements are the elements in which the last electron enters in the outermost S subshell. See, when you look at the periodic table, the elements of group 1, which are actually called as alkali metals, and elements of group 2, which is actually called as alkaline earth metals, they belong to the S block elements. That is, the elements in the S block are hydrogen. Okay, hydrogen is here. Then lithium, sodium, potassium, rubidium, cesium and francium. As well as we have group 2 elements which are also the S block elements. That is beryllium, magnesium, calcium, strontium, barium and radium. So you see, group 1 and group 2 elements are actually belong to the S block elements. So you see, the elements of group 1, which are actually called as alkali metals, and group 2, that is alkaline earth metals, they belong to the S block elements. You see, the outermost electronic configuration of group 1 elements is NS1. You see, this N can have values 1, 2, 3 like that. So for all group 1 elements, its outermost configuration will be like 1s1, 2s1, 3s1 like that. That is in general NS1. Similarly, the outermost electronic configuration for group 2 elements is NS2. That is 1s2, 2s2, 3s2, etc. See, the S block elements are reactive metals with low ionization enthalpies. See, we will be discussing about ionization enthalpy in detail, which is available in the playlist. See, S block elements are reactive metals. That means they readily react with water, oxygen and other elements to form compounds. And S block elements have low ionization enthalpies. That is, they easily lose electrons to form positive ions or cations. In the case of alkali metals, that is the first group elements, they lose the outermost electron readily to form 1 plus ion. This is because the alkali metals have a single electron in their outermost energy level. This single electron in the outermost energy level can be easily removed, resulting in a stable noble gas configuration. That is, when you consider the alkali metal sodium, which is the first group S block element sodium, its atomic number is 11. So electronic configuration is like 1s2, 2s2, 2p6, 3s2. Sorry, 3s1. So in the outermost shell only one electron is there. So they have a tendency to lose this one single electron from the outermost shell. So when sodium loses one single electron from the outermost shell, it becomes a positive ion, that is Na plus ion. That is, sodium loses one electron and it becomes a sodium ion with a noble gas configuration. Noble gas configuration means all shells are completely filled. So 1s is completely filled, 2s is completely filled, 2p is completely filled when one electron is lost from this. Okay, this process is actually known as ionization and it occurs readily in alkali metals due to their low ionization energies. Now, when you consider alkaline earth metals, that is group 2 elements, they lose the outermost electrons readily to form 2 plus ions. That is, the 2 electrons are lost from the outermost shell to form a 2 plus ion, that is a cation with a double positive charge. Because alkaline earth metals have 2 electrons in their outermost energy level, which can be easily removed and resulting in a stable noble gas configuration. For example, when you consider the calcium, which is an alkaline earth metal which belongs to the group 2 family as well as S block family. So for calcium, its atomic number is 20, so electronic configuration would be like this. Its outermost electronic shell is, because here you see 1s is completely filled, 2s is completely filled, 2p is completely filled, 3s is completely filled, 3p is completely filled. Now we have 4s2, which is also completely filled actually. But anyway, the outermost electron is 2. Outermost shell has 2 electrons only. Okay, because the principal quantum number has it is different here. 4 no. Okay, so when calcium loses 2 electrons, it becomes a calcium ion, that is Ca2 plus ion. Okay, and it will have a stable noble gas configuration after this process. That is, when 2 electrons are lost from the outermost energy level, then the total number of electrons will be 18. 18 is actually a noble gas, stable noble gas configuration. The number. Okay, so when calcium loses 2 electrons, it becomes a calcium ion, Ca2 plus ion with a stable noble gas configuration. Stable noble gas configuration means outermost energy level will be fully occupied by the electrons. Okay, see, 1s means K shell, 2s and 2p L shell, 3s and 3p M shell, then when it comes to 4, it is N shell. Okay, now you see, for S block elements, the metallic character and the reactivity increases as we go down the group. Because of high reactivity, they are never found pure in nature. So the metallic character and the reactivity increases for S block elements as we move down the group. Because of their high reactivity, they are never found pure in nature. See, the compounds of the S block elements are predominantly ionic except for lithium and beryllium. See, except for lithium and beryllium, the other S block elements have low ionization energy, making it easy for them to lose electrons and form ions. Lithium and beryllium, they have higher ionization energies, so it is difficult for them to lose electrons and to form ions. So lithium and beryllium compounds, they often exhibit covalent character, meaning they share electrons instead of forming ions. So the compounds of the S block elements are predominantly ionic except for lithium and beryllium. So in this video, we have discussed about the S block elements. We will be discussing the P block, F block, D block elements in our next videos, which will be available in the playlist. Thank you.